Hello everyone. Today we are going to see the project name called Enhancing Deepfake Detection through BiLSTM and Multi-Hit Self-Attention Mechanism. So in our project, our aim is the rapid growth of artificial intelligence. Deepfake images and videos have become a serious threat in areas such as social media, digital forensics, and cybersecurity. Deepfakes are artificially generated or manipulated media where a person's face or actions are altered in a very realistic manner. Traditional image based detection techniques fail to identify these manipulations because deepfakes often contain subtle temporal inconsistencies across video frames. To address this problem, this project brought a very deep learning approach that combines CNN, convolutional neural network, and BiLST, bidirectional long short-term memory. So the CNN model is used to extract spatial features from each frame, while the BiLSTM model captures temporal dependencies across multiple frames. This combination helps in detecting unnatural transitions and inconsistencies present in deepfake content. So the system supports both image and video inputs. Images are converted into frame sequence and videos are processed by extracting multiple frames. The trained model classifies the input as either real or fake. The solution is implemented using PyTorch and deployed through both desktop GUI and web-based Flask application, making it suitable for real-time deepfake detection. So now we'll move on to our block diagram. So this is our block diagram. So first the input block. So the first block accepts here where the system accepts either an image or a video. If the input is a video, frames are extracted from the video. If the input is an image, the same image is replicated to form a sequence. So the next block is pre-processing. So here the pre-processed frames are then passed in. So after sequencing, the frames are pre-processed, which includes resizing the images to 224 into 224 pixels and converting them into tensors and normalizing them using ImageNet standard. This ensures compatibility with the pre-trained. So next, it is move on to the CNN feature extraction. So the pre-processed frames are then passed to CNN feature extraction block, where a pre-trained ResNet 80 network extract high-level spatial features from each frame. So these feature vector are passed sequentially to BiLSTM temporal modeling block. So the BiLSTM processes the sequence in both forward and backward directions, allowing the model to capture temporal inconsistencies and unnatural motion patterns that are common in deepfake videos. Finally, the output of the BiLSTM is passed through a fully connected layer activation function which produces a probability score. Based on this score, the system classifies the input as real or fake. So this is our training code. Here first we are importing all the necessary libraries. After that, we are setting the root data set root. If this is our data set root, and then the sequence root will be stored in the name of data underscore sequence. So here the sequence length is 16. So from our data set, it took 16 frames as a one sequence. Like that, it will store. So we are setting the image size and batch size and epochs and learning right here. So we are using CUDA or else CPU. So here in our project, we are using CPU. So this is for the sequences. So it will group the images. So that image should be JPG, PNG or JPG or JFIF format. So if that image is in these format only, it will accept. So based on that image format, it will gather that into as a folder. So as a zeros and ones. So zero means real and one means fake. How it will take that frames means, so it take the 16 frames. So in that 16 frames, it create one sequence and it store that sequence. The sequence root folder. So this is our data set. From the sequence data set, it took zeros and ones. So it trades through the whole folder. At last, it resizes that images and tensor that image and normalize the image. So after that, it will return the how many images are in that folder, and then it will return it get the folder along with the label. It load all the image paths and that image if it is zero means then it shows some warnings, or else it will return the sequence length and it will resize the images and then it convert that frames. This is our model. So we are using CNN and BiLSTM. We are using hybrid model. In the CNN model, it extract the facial features and facial patterns. So we are using ResNet 18 pre-trained model. So this model extract the facial features like it is already trained. So if we use ResNet 18 means it would be give a good accuracy. For that reason, we are using ResNet 18 here. So here we are delete the last layer. So why we are deleting that means if you keep that layer means so he that will predict based on that ResNet 18 train model. So we are using ResNet 18 for extracting feature purpose only, not for identifying the class labels. So and then we are using CNN by LSTM. So once encoding that CNN, first extracting the features, those features are forwarded to our LSTM model. So our LSTM model will learn the different differences between the images. Based on that, it will predict whether it is a real or fake. How it mean it would took the batch shape and height with color everything, and then it reshape those things, and based on that it will finally predict whether it is a fake or real. So this is our training phase. So in this phase, we are loading our data set, our sequence data set, and then our model. Here our training is started. So our training is like each time it will increase one epochs. So once after training, it will enter the epochs and loss and accuracy. At last, it will store the our model name called the deepfake underscore CNN underscore BiLSTM.pth. So these are all for metrics. So after training, we'll got some plots. For that plots we are giving here. So after that, we'll get the accuracy, precision, recall, and FN score. In another plot, we'll get the training loss of how much we have training loss based on the accuracy, precision, recall, FN. So this is our testing code. Here we are loading our model. So these are all CNN encoded by LSTM. So before how it's taking the image based on that image how it's extracting features, and based on that features how it will move forward to the our LSTM. We are transforming those images like how we had trained our images in the training phase. So this is for image test. So if image test means it will open the file dialog. So we'll choose one image. Based on that image it will resize that image and then it will given to our model. So our model will take if it is the probability is greater than zero point 0.5 means it is fake, or else it will tell as a real in the green color. So this is for play video. So this is for testing the video. Here also like open the file dialog. If you choose the file means it will capture the video and it will read that video. At last it will display 6 frames from that videos. So based on that video, it will pre-process that video and extract the frames from that video. And those frames will be given to our model. So our model will predict whether it is a fake video or real video. This is for a Tinketer layout. So here you can test with the GUI, graphical user interface, and then we are also developed a app code also. This is for a GUI. So in the GUI, we have two buttons like test image, test video. If we click those buttons, means we'll test. So this is our app code. So here also we are importing all the necessary libraries. After that, we are creating one database. So our secret key. So our app secret key and our database name is users database. So here we are giving ID, username, email, password. These data should be stored in our data set. So for a prediction, first we need a login. So for that reason, we are giving here. So this is a password hashing. So this is our model configuration. So our model configuration means like that image should be 224 pixel and the sequence length is 16. So this is our model path. So this is our device, which device we are going to run. So these are all the model definitions. Like already I told in the training and the testing phase already how our model is trained. So here we are loading our model. So these are all the help functions to predict the images. So how means we upload any video means it extract the frames from that video. Based on the frames only it will predict whether it is a fake or real. So these are all our routers. So we have a index, login, register, logout, about router. So in the login, this is our register router. For registration, we need to give username, email, password. Those things will be stored in our database, and then it will redirect to our login page. In the login page, we need to give that email and password which we had used for the registration. And if you give that email password means it will check to our database. If it is already registered means it will allow us to predict, or else it will throw some error. So register once if you log in successfully means then it will redirect to our prediction page. So these are all the video stream in our app. It will show some if we upload video means those video will be displayed in app. For that we are doing here. We are using video stream route also. So this is the prediction. So in the prediction means first we need to upload the image, and that image will be resize, it will be predicted. Same for that video also. From that video it will extract the frames. Based on the extracted frames it will tell. At last it will, in the predicted.html, at last it will show the result and that image frames and along with the video. So once if you run the code means we'll get one link. We need to follow that link. So this is our web page. So here we can start deduction from here also. Once if you register, first I will log out because I already registered. So once if you log out means, so it will redirect our login page. If you already registered means you can directly log in here, or else you need to go back to the registration. And once if you register means will predict. So this is our prediction page. Here we have a testing image and test video. So we'll upload test image first. So zero means, so it is a normal. So I am uploading normal image. So this is the analysis result. So what the image we selected, that image will be showed here with the result. So it's showing real image only. So we'll upload another image. So now we'll click analyze media. So it is also a real image. We'll upload a fake image and we'll test once again. So this is a fake image, so it's showing fake image only. So I uploaded another image also. So it is also same fake image only. So now we will test with the video. We'll choose the file. So I'm choosing a fake video first. So once if upload the video means, so video preview also here it will be displayed, and it will extract the 6 frames from that video, and then at last deduction result. So for same process for real video also, if you click the analyze media means, so video preview will be shown in here. So frames, and then it showing the detection result as real video. So here we have a backup to home button. So here we have a login, register, about prediction, logout button. So this is our about page. So about of the different deductions. So what all we did in our project, those things will be displayed here. What data set we have used, how our model will be trained, our prediction pipeline, like how it is predicting. And then our prediction. So here also we have back to home button. If you click that one directly, our home page will be displayed here. So now here also if you click means will predict because we already logged it. So we'll show you.